In 1969, Dr. Donald Gopin gathered a group of study participants, asked them to each to recall objects he'd shown them to inspire the twist. All the participants were very intoxicated. Despite this, most could pay attention to the task and correctly name the toy they have just seen. Yet, when Donald asked them to recall the object a mere 30 minutes later, how the participant drew a blank, having blacked out the earlier moment entirely. This study illustrates the trend of somewhat selective effect alcohol has on the brain. Many intoxicated people can perform complex tasks like holding a detailed conversation or navigating a walk home. Yet, for those experiencing what is known as a blackout, the memory of these events is quickly forgotten. So how does alcohol cause these memory lapses? First, let's identify the culprit. While a single drink often contains hundreds of different chemical compounds, ethanol is responsible for alcohol's effect on the brain. Ethanol is a lightweight and lipophilic, meaning its structure easily dissolves into fat, like those in the membrane of the outer blood-brain barrier. Once inside the brain, ethanol's unique structure allows it to bind to, interact, and affect many different neural receptors, impairing pathways that allow you to make careful decisions and control your impulses, even manage your motor skills. And networks that control your memory seem to be especially sensitive to alcohol's effect. Typically, information about your surrounding is taken in by your sensory organs and sent to the brain. Neurons transfer this information to one another by a chemical messenger called neurotransmitters, which are released by one neuron, and received by receptors by another. When a neurotransmitter binds to a receptor, it unlocks an internal channel, allowing a small ion to flow into the cell. If enough ion enters the cell, the neuron fires, sending a signal forward. Through this process, different regions of the brain can communicate with one another in milliseconds, creating a moment-to-moment understanding of the world. But ethanol interacts with receptors, making it harder for a neuron to communicate. While compromised, the brain is still able to transfer information, which is why many intoxicated people seem somewhat capable of performing basic tasks. In other words, brain function is highly impaired, but not completely broken. But memory storage is a different story. The transfer of moment-to-moment understanding to something we can remember is thought to depend on a process called long-term potentiation, or LTP. LTP happens throughout the brain, but it is especially important in learning memory regions, like a neurocortex and the hippocampus. During ATP, the firing of neuron triggers physical changes to its structure. For example, more receptors may be moved to its cell surface, making the neuron more sensitive to its future signal. Making the neuron more sensitive to future signaling from its neighbors. These physical changes increase the likelihood the cell will fire again at the connection, strengthening the binding between neurons. And through this stronger connection, it's thought that a stable memory is formed. Yet studies suggest that ethanol has a unique ability to disrupt LTP, blocking the physical changes needed for memory information. So while moment-to-moment information is encoded and understood, the storage of the information is blunted, resulting in a blackout. Of course, not all levels of drinking result in blackout. They happen when the concentration of alcohol in the blood, or BAC, exceeds a certain level, approximately 0.16. But there's no magic number. A slightly lower BAC or brownouts, or slightly lower BAC brownout or spotty memory of events can occur, as some neurons continue to function properly while others fail, and drinking too much can cause the person to pass out altogether. Other factors like dehydration level, genetic differences, and medications, even how much you've eaten, can affect the likelihood of the blackout, and teenagers appear to be especially vulnerable due to substantial changes in the brain development during these years. Alcohol's short-term effects usually don't last longer than the time it takes for the body to metabolize it, and about a day. But repeating over drinking can damage neurons and permanently impair memory. It can also harm other organs, like the liver, which works overtime breaking down alcohol. After all, experiencing a blackout or witnessing others in this compromised state can be a lot for your mind and body to process.